Okay, good morning, everyone. How'd the homework go? Please ask question on chat about the homework. Any questions, please? 3I, 2A, and 6, okay. All right, we start with 3I. All right, so we have the following function. Okay, so the function is f of x equal 1 over sorry, okay. Sin x minus 1. And the question is, we need to find the domain. All right. So what is the domain of this function? It means we have denominator. Means we have to remove all the values of x that make the denominator equal to 0. So we need first to solve, sorry. All right, so we need to solve sin x minus 1 equal to 0, and then we have to remove all those values. So the question is, when the sin of x minus 1 equal to 0? This occurs when sin x equal to 1. And now, when is sin x equal to 1? If we think about the graph of the sine, we start at 0, goes up at pi over 2, goes down, back up. Then it does the same. Go up, go back, and go down. So the sin x equal to 1, and it does this from here. For which value of x? Here, it's at pi over 2. Not only that, at pi over 2 plus 2 pi. Not only that. So this would give me pi over 2 plus 2 pi. Not only that, at pi over 2 plus 4 pi. Okay, so when is sin x equal to 1? Equal to 1 for x equal pi over 2. Not only x equal pi over 2. X equal pi over 2 plus 2 pi. Pi over 2 plus 4 pi. And so on and so forth. So what's going to be the domain? The domain going to be all values of x such that x is different from pi over 2. Now, instead of writing plus 2 pi, plus 4 pi, etc., we can write this as a plus 2k pi, so all the multiple of 2 pi, where my k could be 0, 1, sorry. K is any integer, including positive integers, plus or minus 1, plus or minus 2, and so on and so forth. Okay, so if I put any value, if I put pi over 2, if I put pi over 2 plus 2 pi, pi over 2 minus 2 pi, and so on and so forth, this will make the denominator equal to 0. We have to be removed from the domain. Okay? Any questions about this one?
How would you put that in interval notation?
Oh, we can't. No, we can't. Because those are isolated points. All right, so those are isolated points. There is no reason for us to put them in interval notation. All right? Okay, let's look at 2a. What is 2a about? 2a is 2a, Patrick. All right, so we have find all angle between 0 and 2 pi, so cosine equal to a half. So, okay, cosine equal a half. We want to find all angle between 0 and 2 pi. All right, if I want to cosine equal a half, I'm going to think about that on the unit circle. Now, if I know one angle whose cosine equal a half, we can find other. And I only am asking for the angle between 0 and 2 pi. Whose angle has cosine a half? Now we know the particular angle, and we know one of them. We know pi over 3. So that's the one we should know. So theta equal pi over 3. Now that, is this the only angle? Can anybody give me an angle whose cosine pi over 3? Just using the idea of the unit circle. Who can give me another one? Anybody? Pi over 3, that's one of them. I want another one. 5 pi over 3. Let's see how we can get another one. If you remember the definition of the units of the cosine, if I take the angle right here, so if I do that, and I take the following angle, this one also has for cosine. So just by looking at the unit circle, this one has also cosine 1/2. But what's this angle here? So the other one, which is the red one, is nothing more than 2 pi minus pi over 3, which is exactly 5 pi over 3. Okay, so we just have to look at the unit circle and we can find everything. Very good. Now let me go back and see which other questions you have. 6 and 30 and 6 and nearly 3b, I imagine. Nearly, is it 3b or what? 5b. Okay, so we're going to do number 6 and then 5b. So let's do them in order. So let's look at number 5b. All right, so we have the following function. Let's pick up a clean piece of paper and do number 5. Actually, number 5 is number 5. So here's the question. We have the following function, f of x equal sine square x. Okay, I'm going to do A and then I will do B. Sine square x. And the function, the question is to write this as a composition of two functions. Okay, so how are we going to do that? Okay. First, let us remember what sine is. Sine squared, that's sine x to the power 2. And my question is, I want you to write as the composition of two functions, h and g. So it means I want you to find the inner function, h, and the outer. So that when you compose them, you get sine x to the power 2. So what do you think is the inner? So basically, remember, if you want to compute this expression, what would you do first? What would you do second? So what's going to be the inner function? The inner is, no, if I pick gx, remember we're doing this one. Suppose I pick the inner to be x squared. And the outer, it means h to be sine. Then when I compose them, what do I get? H composed with g, I will get h of x squared. It means the sine of x squared. So that's not right for the inner function. We're doing sine square x. This will give me sine x squared, and that's not what we really have. So what's going to be the g? The inside function. So if I pick g to be x squared, I have sine of x squared. That's not really what I want. What's going to be my inside? And my inside will have to be the sine, because if you are computing this, first you do the sine. After you do the sine, you are going to square it. So sine is going to be your inside function, and the squaring is going to be the outside function. And now let us check. Let me compute with this choice. Let me compute h composed with g. It's h of g of x. Which is, what's h? What does h do? It's square, which is sine square x. Right? Now, yes.
On the worksheet, is it the same thing? Is it because the sine of x squared, or is it sine?
Very different. Very different. This is sine square. This is such
Okay.
it means that's very different. Now the second one was, my second problem was sine x squared. So this was A. My second one was sine of x squared.
Okay.
Correct?
Mm-hmm.
And this one, I want you to write it as the composition. Okay? For this one, what's your insight? What's the G? So I want you to write this as H of G. Now, what is G in this scenario? And what's H in that scenario?
The x squared and
That will be x squared. That will be the insight. So first, you're going to square the x. And after you do this operation, you're going to take its sign.
okay, that makes sense.
All right? So very different. Very different. And that's crucial. That's why I put both of them in the problem. So you guys make the distinction between them. All right? Okay, we look at the last one. And number 6. Which is, we have a function f of x. And it is the square root of 1 plus tangent square x. And my function is, I want you to write it as a composition of 3 functions. In other words, I want you to find 3 functions. Let's call them h and g and l. And I want you just to write it as a composition. Sorry. Okay, so let me start. I want you to give me what's going to be the L, and then what's the G, and what's the H. So what would you do first? What would you do second? So there are a lot of choices. And what would you do at the end? Okay, what did you guys come up with? Anybody, what kind of answer you got? You did? L is x squared. L is, remember, L is the inside. L is the first thing you do. H is the last thing you do. So ask yourself, what would you do first? If you
Square
square root of x, will not do it. If you're not squaring first, what do you have to do first? Okay. There are a lot of scenarios. One scenario is, all right, now I'm getting it. You first, one approach, just one scenario. You take the tangent, right? The second operation, after you take it, you square it. So you're doing the squaring operation and you add 1. That's absolutely a possible scenario. The last scenario you did, the last thing you did, the h, is the squaring operation. So that's a possible scenario for the function. So you take the tangent, and then you take 1 plus the tangent square, and then you can take the square root. Okay, so that's absolutely a possibility. Now, I have other choices. So some students are telling me the following. I will take another scenario. Okay, so Wyatt is telling me you can first take the tangent square. Absolutely correct. If I do that, my second operation, I can take 1 plus whatever I did. And the last operation could be squaring. That's another scenario. Okay, so there are a lot of scenarios for this problem, not only one, and that's how we do it. Okay? Any other questions? All right, So today we're going to move to chapter 2, and we're going to just start having an idea about chapter 2, and I'm going to do chapter 2.2, the idea of element. Okay, so today we're just going to have an introduction, and then we start working with them a little bit more tomorrow. So let me motivate it in a simple scenario. Here, suppose I have the following function. Let me say f of x equal x to the power 3, let us say, minus 1 over x minus 1. Okay, not a nice function. And here's the question. What's the domain of this function? For which value of x this function doesn't make sense? Quickly. Okay, x equal to 1. So the question here that the function is not defined at x equal to 1. But if I take a value of x very close to 1, this function makes sense. So even if I take x to be 0.999, there is no problem with that. The function makes sense. So it doesn't make sense at 1, but it makes sense close to 1. So my question is, this is the question, what happened to the output value? It means the value of f of x. The value of f of x, these are what we call the output, when x is close to 1. But definitely not 1, because 1 doesn't make sense. So that's really what my question is. So what's really happening here? So this is my function. I'm not going to graph it because I have no idea. And this is 1 right here. I'm asking myself, what happened when you are close to 1? So the only way we're going to do that is actually we're going to make a table. And I'm going to take x, and here the f of x. I'm going to take values close to 1 and start wondering what's really going on. And I'm going to make two tables because on one, I'm going to take values close to 1, but let us say bigger, and one less. I'm going to split them into different tables. All right. So I'm just going to pick my calculator, no more, no less, and start computing this and see what is really going on. So let me pick my calculator. I hope you guys have one. Okay. Right, and let us take some values. All right, so which values I want to take? So I'm going to take the value 1.1, and I'm going to nothing more than evaluate the function, because I'm going to take what happened near 1 to 1. Means I'm going to take 1 to 1. I'm going to plug it in the expression of the function, minus 1. And I'm going to take my calculator, pure and simple, and evaluate this. So I'm going to, it doesn't show well for you. Okay, I'm picking up my calculator. I'm using my calculator to compute this number. So basically I'm taking, you guys can do it with me, see if we get the same answer. So 1.1 to the power 3 minus 1 divided by 1.1 minus 1, which is 0.1. So I'm getting 3.31. Okay, right? So you guys can do this actually with me. And then I'm going to take a value even closer. So I'm going to take, let us say, 1.01. And I'm going to compute the output at 1.01. And I'm going to do that exactly by plugging into the calculator. So we plug it into the calculator and we get 3.0301. Okay. And then I'm going to get something even closer. So closer to 1. So this is my 1. And I'm picking up values close to 1. So I'm getting, so if this is 3, right here, I'm getting a little bit more than 3.31. Then I'm getting something even closer to 3.01. And I'm going to take 1.001 and again plug it into my calculator. And if I did, I get 0, 0, I think. No, sorry, let me do it again. So 1.001 to the power 3 minus 1. So it's going to give me 3.003. Okay. And I can keep doing this. I can keep doing this. And then what do I realize for the output value? So the output value, when I keep taking those values close to 1 in here, those seems to be getting close to 3. Okay. Now I can do that, or we will do that, but so from here, this is getting at 3, the function makes no sense, but those values seem to be getting close to 3. Now I can do that for x less than 1. So I'm gonna do that x and f of x, but I'm gonna take values less than 1. So what is value less than 1? What do I mean by that? Less than 1. Okay, I can take 0.9 and find the output. So let me do that. So 0.9 to the power 3. I'm just computing really. Minus 1 divided by 0.9 minus 1. And I'm getting 2.71. So at 0.9, I am down here. So I'm going to get values closer. So I'm going to get close faster, 0.99, because it's boring otherwise. So I will take 0.99 to the power 3 minus 1. And now I'm getting 2.97. Okay, I'll take one more value because it will be very boring otherwise. So 0.999 and 0.999 to the power 3 minus 1. And I'm getting 2.99. And actually 997. All right, so if I take value less than 1, so my function is taking value 2.7, and then 2.97, 2.997, and it seems to be again taking values which are getting closer and closer to 1. Okay, so at 1, the function makes no sense whatsoever. But as we get close to 1, my function is taking value close to 3. At 1, it's not defined, but very, very close to 1, the function is taking values close to 3. So how are we going to write that mathematically? So it means as x become close to 1, so this notation means as x become close to 1, the output value f of x is taking value close to 3. So f of x is taking value close to 3. So we write this the following. We say that the limit as x become close to 1 of f of x, or the limit, we write this the limit, Lim, as x become close to 1, f of x is x to the power 3 minus 1 over x minus 1. When x become close to 1, this expression become close to 3. Okay, so what does it mean to say that the limit of a function? So can I move on? Anybody still writing? Okay, so what is the definition of a limit? So let us read it a little bit. So this is like an informal definition. So I will read it very carefully. So suppose y is a function and defined on both sides of a point A. It means it makes sense near A, not necessarily at the point A. So I have a function that I have a point A, sorry, and my function doesn't make sense at A. I don't think this graph is working here. So this is my function right there. This is a point A, and my function at A doesn't not define. There is no output at A. Then we say that the limit as x goes to A of f of x equal to L, or f of x become close to L as x goes to A, So that's how do we read this? We read this as the limit of f as x approaches L if the following happen. Intuitively, it means that if we can make the output value of f very close, as close as we want to L. So if you can make the output value very close to L by taking x very close to A. Okay, so we say that the limit is equal to L if we can make the output value very close to L when x is very close to A. And here I'm saying it's very close to A from both sides. What do I mean by both sides? It means when they are less than A and bigger than A. So I want x to be close to A, but not equal to A. I don't care about the output at A because it most of the time doesn't exist. What I care about is what happened to the value of f when x is close to A from both sides. So always graphically, it's the following. My point A, that's the picture in my mind, and that's the number L. And what we're saying is that at A, the function, I don't care about the value of x of the function at A, but the output values become very close to L when x becomes close to A. So the output becomes close to L, but the function is not definitely defined at A. Okay, so let us take 2 examples and then we take a graphical one. So I want you to do the following. I want you to pick your calculator yourself. And I want you to find the following limit. Okay, so please pick up your calculator and find me the following. So I'm going to take the limit. I want you to find the following limit. This one you need a calculator for. Limit as a simple one. Limit as x becomes close to 2 of x squared minus 4 over x minus 2. All right. So, and I want you to find by using the same thing, the same approach I did at the beginning. I want you to find what happened to this. And not that x equal to 2, the function doesn't make sense. That's why I'm asking you when x is close to 2. So pick up your calculator and tell me what should happen. So I want to table. I want x, and I want, this is the output, x, this is the output. And the reason I put 2 table because I want the values of x to be less and big. And the question is, what's going to be the limit? So, okay, tell me which value you want to take. Put on chat which value you think we should be taking, and we can take all of them. 2.1. Okay, and we're gonna get even closer, 2.01, a little bit closer, a little bit, don't be afraid, 2.001. So let us, all of us, find those values, and then we take x less than 2 and see what's really happening in this scenario. Okay, and I'm computing them the same way you are because, you know, you picked the value, I didn't. .1 squared minus 1 divided by okay, so how much you're getting for the first one? How much you guys are getting? 4.1. And how much you're getting here? Anybody finished it? 4.01, Gavin. And how much you getting here? Anybody finish that one? For Morgan, 4.001. Okay, so it seems to be definitely getting close to 4. Now let's take some negative value, some value less than 2 and see what's happening. So less than 2, who wanna give me value less than 2? Quickly.
0.9.
For how much?
1.9.
1.9, yeah, that makes sense. And then you can do, let us say 1.95. We don't want to do always 1.99. And then we do one more, 1.999, for example, and see what's happening. So here the values are becoming close to 2. And let's see what's happening to the value here. Okay, are we getting that? Sorry, it kicked me. Oh, that's fine, Ali. Okay, what value are you guys getting? This should be that 3.9 here. 4.013, somehow I doubt you can get that. It's 3.95. Just plug in the numbers back into your calculator. And right here,
3.999.
3.999. So again, we realize that the values are getting closer and closer to 4. Okay, and so we suggest that the limit is equal to 4. So if we actually graph this function, what do I mean by graph it? Means if we pick up our calculator and we graph using the calculator, at 2, we're gonna have definitely an open circle because the function is really, and around 2, according to the numbers, we're gonna look something like that. And after that, I don't care. I care about what's happening at 2. Okay, so when we're finding this limit, what happened exactly at 2, I don't care, never. What I care about is near 2, what's gonna happen. So let us do one more problem. And I want you to do the following. I want you to find the limit as x become close to 0 of the absolute value of x over x. Okay, and again, I'll give you 2 minutes to do that. All right, any ideas what's happening? Again, we're going to do both tables. So this is x, and this is my output here, and this is x, and this you don't really need any calculator whatsoever because those are easy to do. All right, let's take some value close to 2, and let us take here the value bigger than 2 and here less than 2. Bigger than 0 and less than 0, because the issue here, when I write the limit as x equal to x become close to 0, the issue is really becoming at 0. So what values less than 0 we're gonna, bigger than 0 we want? Who would like to give me a bunch of values? Quickly. 0.1, 0.01, and 0.001, and then we see what's really going on. All right, at 0.1, what is the output? It's the absolute value of 0.1 over 0.1. But the absolute value of 0.1 is a positive number, so the absolute value is 0.1. So it's 0.1 over 0.1, which is a 1. At 0.01, again, 0.01 is a positive number, so the absolute value is 0.01 over 0.01, which is absolutely a 1. Again, a 1. Again, even if I take any smaller value, I'm getting a 1. So let us draw the picture here. What's going to be the picture? So I will draw the picture here. Okay. So this is the table we're drawing, and that's the graph. So this is my 0, where I have an issue. And then what's happening after that? If I take 0.1, I'm having 1. 0.01, I'm having 1. 0.02, I'm having 0.001, I'm having 1. So all the values here are actually 1, and right here I definitely have an open circle. So that's an open circle. Otherwise, the output are 1. Now, let us see what's happening when x is negative. So what's happening when x is negative, all right? So let's take minus 0.1, for example, minus 0.01, minus 0.001, and let us see. What is the value here? The absolute value of minus 0.1 is actually 1. Divided by 1, sorry, it's 0.1. Divided by minus 0.1 is minus 1. Okay, so here, when x is negative, the absolute x is definitely a positive number, but the x is negative, so those two, they have the same basically absolute value, but the sign is gonna always be the negative. Because if I, again, think here, that's the absolute minus 0.1 over the same thing, but a negative sign. This is, again, gonna give me a minus 1. Minus 0.1 is also gonna give me the minus 1. So on the picture here, so in this sense, this is gonna become close to minus 1, and this one is gonna be close to 1. So when x equals close to 0, what we're going to say? Let's go back to this picture here. When x is negative, the values are minus 1. So this is minus 1, minus 1, minus 1, minus 1. And this is 1. So what we say in this scenario, we're going to say that the limit as x goes to 0 of this function does not exist. Okay. So for the limit to exist, it means the following. For the limit to exist, it means this following picture should occur. So this is a point A. For the limit to be equal to L to exist, it means that if I take all, no matter which value I take close to A, whether bigger than A and larger than A, all the output has to become fixed to one number, not to two different numbers. Now here, when I start taking values close to 0, but positive and negative, I did not have the same value. It means the output value did not get close to a fixed number near 1. In this case, that the limit does not exist. And this is going to bring up also the following definition. So we're going to also talk about the following definition, something called one-sided limit. So this picture here is actually bringing the following definition, one-sided limit. It's very easy. We say that the limit as x become close to A from the positive of f of x equal to L. What does it mean? In word, that the output values become close to L when x become close to A, very close to A, but strictly larger than A. So we say that the limit as x become close to A from the positive or from the right, which means that's the picture. This is my A, and this, let us say, a number L. Limit as x become close to A. It means when we take output, the input value close to A but larger, the output become close to A. Now, by the same token, we say that the limit as x become close to a from the negative of f of x equal to L, this means that the output values become close to L when x become close to a, but strictly less than a. It means from the left. So we say that the limit is equal to L when x become close to a from the negative. It means when we are only interested to the value of x less than a, the output become close to L. So, and the picture like here is the following. This is my a, and this is my L. It means the values become close from here. Okay. So in the right, please questions as I move on. All right. So in this problem, in the problem that we did a minute ago, so this was my 0, and we had some values becoming close to 1 and some values becoming close to -1. So in this scenario, graphically at least, we say that the limit as x become close to 0 from the positive of my function, this is my function here, which was the absolute value of x is equal to 1. And the limit when x become close to 0 from the negative or from the left is equal to -1. But the limit itself of f of x as x goes to 1 does not exist. All right? So for the limit exists, as I said, at a point, regardless how we approach this point, the output should become close to the same value, exactly the same. If it doesn't, then the limit doesn't exist. So here we can write the following. If the limit from the left is different from the limit from the right, this is occur, then the limit as x goes to 8 of the function does not exist. So one way the limit does not exist is for the limit from both the left and the right not to be the same. Okay. So we're going to take now a simple graphical example. So it means I'm going to give you a function by a graph, and we are going to answer some questions. Okay. So the limit, it means you have to always think from both sides the values coincide. We only have problem at the point A. Right? So let us now take the following examples. So that's a function, and that's the graph. And I will ask, simple questions about this function. Okay. So question number 1, find f of 1. Okay, I expect answers on chat. What is f of 1 in this particular problem? Remember, closed circle, it means, so it's absolutely 3 because a closed circle. Simple. What's the limit as x become close to 1 from the minus of f of x? So what am I interested in? I'm interested in anybody? Yeah, so this is 1 from here. These are the output value. This is what I am interested in. So I'm interested in those, and the value is equal to 2. Okay. Now what's the limit from the right? Of f of x. Okay, 3, you're right, because absolutely 3. And now what's the limit of f of x as x become close to 1? Does not exist. And what's the reason? So does not exist, of course, does not exist, does not exist. And the reason is because the limit from the left, that's how you're gonna justify it, is different than the limit from the right. So it doesn't exist because both limits are different from one another. All right, one more questions. What is f of 2? What is f of 2? Okay, doesn't exist, is absolutely, it's undefined. Now, what is the limit? As x goes to 2 of f of x. Three, do you agree? Everybody? Yeah, because the limit from the left is 3. The limit from the right is 3. Limit from the left and limit from the right agree with each other. It means they are equal. It means the limit is actually equal to 3. Okay, so graphically, you know, and by plugging numbers into a calculator, finding the limit is actually not very hard. So what we're going to start doing it tomorrow is a little bit algebraically. So how can we find, if I have a function as given by a formula, how can we find some of those limits algebraically, all right? We stop at this stage. For tomorrow, your homework will be on my lab and will be very much what we did today. Okay, any questions before I end the meeting? Any questions? Okay, so till tomorrow. So as I said, your homework now will be on my lab. Bye-bye for now.